two, all right, and hold them together here, not being carbon, it's just going to lay flat. All right, so you're going to count this as one. All right, so it still comes out as AX2.
So when we see a diagram of it, how do we tell if it's a double bond or a single bond?
You're going to count, so if it's a double bond, you're going to count it, for the most part, you're going to count it as one, because it's together.
How do we know about the
Yeah.
diagrams all look have a single?
I know. I wouldn't do that. Yeah. Well, for the most part, that's the way we're going to try it. I am going to keep it for you guys because I don't want to make it any more complicated than it is. All right. So if you have, the only one I usually use is carbon dioxide. It's the one that usually shows up on the exam. So hint.
Wait.
Yeah. Because the electrons will pull it apart, they actually lays flat, so it's linear. So the shape is linear. Okay, and then we go to the next one. So pull three of them together. All right, now this one. All right, we're going to deal with the fact that these are all electron pairs. So we're going to deal with the fact that we don't have any lone pairs. All right, so we're going to ignore the one that's on the next one over the bent one for the minute. All right, so that would represent AX.
So that may wonder why it's
3. Okay, so if you were to leave that and tie them together and leave it, it wouldn't go. It would end up being
like this.
Yeah.
Like change shape.
Right. It would actually look like a tripod, right?
Yeah.
Right. So we call it triangular planar. Yeah. Right. And for me right now, I don't like to get it bent. So we need to have a little bit of a discussion here because Mr. Armstrong is, I don't know why he likes to do this to you guys, but he likes to throw the bond angles in there. Okay? And it becomes a pain in the butt when we get to the lone pairs. Okay? So if you end up with anything that's AX, and that's it, okay? Just take the number that's for the X and divide it by 360. Okay? Right? So for all the ones, if you look on that this page right here, right, and deal with this column here only. All right? So like AX3, AX4, all right? If there's no E attached to it, just take the number that's below the X and divide by 360 to get the bond angle. All right?
Does that mean every bond angle is equal?
Yeah, for those it is, right? So because the electron pair is not going to affect them, right? So we're not going to deal with this guy right now because it totally messes.
If you put a lone pair in here,
It's going to change the angle, so you're going to have a different number, right? Because some other, like if you're looking about water, most people think water is exactly this. It's not.
What's it equal to X divided by?
Okay, so the subscript of the X divided by 360. So 360 divided by the subscript.
If it's only AX.
If it's only AX.
If E is not present.
Right, so no E.
That equals to the X.
That's a bond angle. So that's how far apart each of the electron pairs are. Okay? So we start with the first one's 180, second one's 120, and then if we add a third one, yeah.
If you add the extra, the lone electron pair, right, it forces the others to move apart, but
not all of them.
Oh, okay.
So what happens is you end up with one part being, you'll end up with one part being wider apart. So for example, if we deal with water, like this, right, this part will be a different angle than that angle. Right, because remember I said it's kind of like you have an extra thing there, right? So this thing here will be a much bigger, further part than that.
So all the angles, the angles aren't the same in the extra pair.
Okay, so is everybody okay with that part of the
So that's only for stuff that does not need.
Right. Okay, so
then he wonders why
we're not going. I won't ask. I know I won't ask you about if you have it. The only one I will ask you about is water. like in terms of what the bond angle is, because it's the most important molecule you guys need to know, but we haven't got there yet.
So 180.
That's not 180.
It has E. Yeah, it has E.
Okay, so
It's not in this.
So going back, if you have
It is?
two,
Yes.
you have two lone pairs, you got linear, right?
And
You have
that.
3, you have triangular planar. Okay, you got 4, tetrahedral, right? Okay, you got 5. Alright, so it looks like that lovely molecule that some of you had in your hands, okay? And if you have 6, you got octahedral.
Why is it octa?
Well, why would it be called octahedral?
Octagon.
Well, there's 6, but how many different